everyone, and welcome to the first Sparkplug Working Group Community Meeting. Hopefully not the last, but the first one. My name is Arlen Nipper, and I'm the current chair of the Sparkplug Working Group Steering Committee, and I'm glad you've all been able to join this call and hope that it's both interesting and informative for everyone. Today, we're joined by Frederick Desbiens from the Eclipse Foundation, Todd Anslinger from Chevron, and Wes Johnson from CirrusLink Solutions. As you can imagine, it's been a thrill for me personally to watch the evolution of MQTT over the last 22 years. When Andy Sanford Clark and I started on the development on a project for Phillips 66, we had no idea where its adoption would be today. But I think much more important to the actual technology that we worked on, the specification, was the fact that Andy and I worked very hard to keep the specification open to the community at large. That openness involved into things like the PAHO project at the Eclipse Foundation, alongside the broad open source projects like Node-RED, and the fact that every Raspberry Pi ships with Node-RED. So unlike the litany of the 40 years of industrial protocols that all of us in OT have to work with, MQTT is well known globally, from high school students to data scientists to IT professionals, and now even within the IIoT community. Due to that success, we're taking the same approach with Sparkplug and its open source community within the Eclipse Software Foundation. So with that, I'd like to introduce Frederick and have him go through just a background and introduction to who and what the Eclipse Foundation is. So Frederick, over to you.
Thank you, Alan, and welcome everyone to this meeting. So as Alan said, I'm Frédéric Desbiens, the program manager for IoT and Edge Computing at the Eclipse Foundation. And essentially, my role is to support our community in building all of those great innovations, including Sparkplug. So to get started and get you to understand what the Eclipse Foundation is doing, I think there's one very broad statement that I will be making first, and Arlen is a big fan of this sentence, which comes from our executive director, Mike Milinkovic. The fact that software is literally eating the world. You know, we live in a world where essentially right now, because of the pandemic and the various restrictions it created on the fabrication of semiconductors, you have car factories that are slowed down right now because they don't have enough computer chips to put in the cars. And then when you think about, let's say, the troubles of the Boeing 737, most of the issues around that plane have been centered on its flight software, right, and a specific component of it. Although the fact that it didn't have redundant sensors also played a factor into its troubles. So whatever way you consider it, software is eating the world. Software is everywhere, and software is certainly not only the future, but the present of industrial automation. And it is in this context that the Sparkplug specification is happening. Another important thing to realize is that to create an ecosystem, you need to be open, right? We're trying to build an ecosystem around Sparkplug, and this means you need to do everything in the open for those things to happen. And a good example for that, you know, to illustrate how important openness is beer, or maybe wine, or think about your favorite beverage, you know, it still applies. You know, beer has been discovered by accident by ancient Egyptians roughly 2,000, 3,000 years ago. And you know, it was pure accident. So some water seeped in a silo for grain, and you know, magically beer happened, and people tasted it and liked it and figured out what the process is. So can you imagine a world where the industrial process for beer would be a closed secret? You know, only a few Egyptian companies would be making beer, and no, this is completely unimaginable, right? So what makes beer great is that, you know, the basic principles to make it is an open secret. You know, anyone can get started. You can even brew some at your home, and then what makes beer great is the fact that you have all of those beers from all around the world that are different takes on the basic concept and principles. And so in one way, what we're trying to do with Sparkplug is exactly the same, right? Sparkplug, by being an open specification, an open source specification, it means that, you know, there will be various takes on Sparkplug, various types of software stacks, various types of devices that will implement it. And overall, this is how you create an ecosystem which is open and collaborative. All right, which brings us to the Eclipse Foundation. You know, software is eating the world, and open source is the right way to do it. So the Eclipse Foundation is the place where you make, or where we make collectively those things happen. So we are a community-driven, code-first, commercial-friendly open source community. And really, the emphasis here is that, yes, the foundation has staff like myself, but ultimately it's our contributors, you know, Arlen and Wes and others from many of our members, and we'll expand a bit on our current members for Sparkplug later. But really, what really drives us forward is this innovation and collaboration that happens among our members. The staff is just there to support, and it's exciting for me to be supporting the wider Sparkplug community. All right, so just to give you a taste, you know, Sparkplug is just a tiny bit of what is happening at the Eclipse Foundation. So we, as an open source community, have close to 400 projects now, close to 350 members, tons and tons of code, obviously, and everything that we do with, roughly speaking, a staff of 35 spread between Europe and North America. And really, what is important is that, you know, we, in the IT space, we've been known for a long time for our development tools, but this is just one of the 4 pillars that we've got. Okay, cloud native Java, automotive are 2 other important centers of interest that we've got, and IoT and Edge is one of those pillars. So we make meaningful investments in this to support Sparkplug and other IoT and Edge initiatives. And really what we bring to the table is a set of processes, ecosystem development, marketing services and initiatives, IP management and infrastructure to support our various projects. But once again, all of the innovation comes from our members. Which brings us to the Sparkplug working group. And Sparkplug as a working group is really something special, in the sense that CirrusLink, you know, came up with the first revisions of the specification. They contributed this to the Eclipse Foundation, and it's now managed by the Eclipse Foundation. But really, what Sparkplug is trying to do is to solve one big specific problem in MQTT-based industrial IoT solutions. And Arlen, you know, will certainly expand a bit on this on his own. So Arlen, if you're ready to jump back, I think it would be your turn to really dig a bit deeper on this.
All right. So Sparkplug, first of all, why did we do it? You know, the beautiful thing about MQTT is that you can publish anything you want on any topic. The problem with MQTT is you can publish anything you want on any topic. So when we started CirrusLink, we started looking out, and there were a lot of people doing Sparkplug. There were OEMs putting, or sorry, MQTT. There were OEMs putting it on their equipment. There were IT companies putting it in their clouds. So we had all these implementations of MQTT, but the problem was everybody was doing it differently. Everybody was publishing something on a topic. We didn't know what it was. They had a payload definition that they had come up with. We didn't know what that was. So that's when, to Frederick's point, CirrusLink sat down and said, look, you know, we've been doing OT-centric MQTT projects for the last 18 years. So let's take best practices. Let's take all the lessons learned, all of the mistakes that we made that we had to go back and fix. Let's pull all those together, and let's create a specification that says, if you want to implement a mission critical real-time operational system utilizing MQTT, this would probably be a very good place to start. So let's standardize our topic payload, or our topic definitions, and let's standardize our payloads to the point where now we can all be interoperable. Now, to that point, we took that and we contributed it to the Eclipse Foundation. And this is following the same success that Andy and I saw with the PAHO project in Eclipse. So that I imagine right now probably 80, 90, 99% of everybody just starting with MQTT have probably gone to the Eclipse Foundation. They've downloaded some of the reference implementation code from PAHO, and they've gotten started. So this is the members of the Sparkplug working group as it stands today. A shout out to Opto22 as they joined yesterday. So Benson, good job. So it consists of Canary, Chevron, CirrusLink, Inductive Automation, HiveMQ, Intel, Opto22, SignalFire, and the University of Sheffield. And if you haven't seen what the University of Sheffield are doing with MQTT and Sparkplug, it's pretty cool. You should go look at that. So, we got this notion of the Internet of People scaled, and they scaled very quickly. And they scaled because they had an open transport, HTTP, and it had been around for a while. And then, this thing came along called HTML that said, hey, people are using this transport. What if we define what was in that transport? And all of a sudden, the Internet of People exploded. We need to have that same notion in, the industrial Internet of Things, Factory 4.0, whatever you want to call it. But we've been talking about this for the last 5-6 years, and I don't believe that it scaled at the rate that people first thought it would. And I think for us to scale at that rate, we need to look at it and say, look, MQTT has become the dominant IoT messaging transport that's open and simple. But we need a HTML, if you will, of MQTT, and that's Sparkplug. It's an open specification that defines the structure and the states of messages within MQTT. And I want to point out here that Sparkplug does not change MQTT whatsoever. It just sets on top of it. So if we look at kind of the bullet points that we've had before, and let's kind of put an aspect to each of the bullet points of Sparkplug. So what does a defined topic namespace do for us? Well, in big terms, it's plug and play auto discovery. In other words, I can go in, I can do a wildcard subscription, and I can figure out what's going on out there. I can find devices, I can look at data, I can send commands, I can monitor my state. But to do that, I've got to have a topic namespace that we all agree on. Now, the second thing is being able to define measurements, and even more so, this notion of being able to define a model from all the way at the edge. So we spend all of this time, taking register value pairs from legacy protocols and pumping them into data lakes, and then trying to sort that out and recreate the models that we probably already knew at the control engineering level. What if we could take that and publish that model, and then instantiate that model to let us start building those machine models just like they existed out in the field? And that's what we're seeing happen more and more as customers not only come into their SCADA HMI systems, but more importantly, as they scale into cloud solutions going forward. The other thing that Sparkplug does is it gives us the notion of a process variable object, a real object, not a register value pair that has no context and it's not attached to a timestamp and you don't remember what the engineering units were. With Sparkplug, you've got the ability to create an object that says, this is a measurement, this is a process variable, and here's its name, its value, its timestamp, its data type, engineering units, ranges, quality, and with Sparkplug, any other custom property that you want to add to that. Finally, Sparkplug defines that thing that a lot of people don't read. They go through the MQTT spec and they go, oh, cool, we can publish, we can subscribe. Let's stop reading the spec. Well, the rest of the spec says we have a last will and testament. We've got state management. So if we can define that, that means that we can publish data report by exception. That gives us the ability for bidirectional command and control where required. And most importantly, and very uniquely, we know when the network went down. We've got a process variable object with a timestamp, so that lets us do store and forward. So it's interesting, as we've watched this 4 years ago, everybody just dealt with the fact that when their network went down, they had holes in their database. Whereas now everybody is asking for that store and forward capability. Very quickly, I think everybody knows that MQTT was kind of born out of the oil and gas industry, and therefore that's the only market that it's used in, when in fact, we're finding that this is our kind of MQTT sales last year from CirrusLink perspective, and this is the markets that are starting to utilize MQTT today. So with that, Frederick, I'm going to hand it back over to you as you go through what is an Eclipse specification and how does it work?
Okay, so before we get to, that's okay. Before we get to Frederick talking about that, I wanted to bring an end user perspective, and that is what's the value of Sparkplug, number one, to Chevron, and what's the value of being a member of the Eclipse Foundation at the end. So in order to set that up, I wanted to kind of give you just where I'm coming from, and you guys probably, this is the same thing you're used to dealing with. Imagine each of these boxes, it's a separate integration point, right? You got to run conduit and wire to the PLC, you have your PLC integrator, maybe the same as the local touchscreen integrator, the control room HMI integrator. You know, all this work is being done sequentially because you have to have the PLC programming done first before you can link to it with the touchscreen and verify your points using poll response. Same with the control room. Control room has to go back to the PLC to verify the points. Once you get it there, you have to dump it out to the Pi server in our case. Then you got to get your Pi administrator involved. He's going to move it from there through the firewall to the data aggregator for the decision support center and their graphics, and then move it through the firewall again to the business system so the engineers can do training against it. You know, that's one level across the bottom. You know, across the top, then we do some proprietary flat file moving into the DMZ and then pushing that into production database. So very labor intensive for standard cookie cutter upstream facilities that we're talking about here. So you can see there at the bottom, it says, you know, it takes 4 weeks of integration time by the time you start the PLC stuff and then hand off and say, hey, it's ready for the next step. You know, you've got, you know, a day or two in between there. And then for everyone to get their job done, it takes quite a bit of time. So going on to the next one, I wanted to show what we did a couple years ago for to see how long it really took compared to a publisher subscriber system. So these are the architectures that we use for our testing. You know, the first one on the left, that is some of our Chevron business unit quasi-standard setups. You have one vendor's PLC and touchscreen, a separate vendor's control room HMI graphics, and then a third vendor for the data historian. That was one system. The next system we tested was a single vendor PLC, touchscreen, HMI, historian, all same vendor. And then the last one was what I'll call version 1 of publisher subscriber. This was, because this was several years ago, is really a pub sub setup with the caveat that we're also getting the mobility piece in the cloud. So that gets us to the next one, which normally it's really lots of suspense and, pull you in, but it came out to be that to do our competitor or Chevron standard system, just for adding a simple tank object and linking it to the hard input, and then doing your different touchscreen HMI historian dumps, took 22 minutes for seasoned people, these weren't newbies, to do that one adding of a tank object, okay? Then the second system with, a common tag name database, you would expect you take about 50% of the time. That's what it did. And then with PubSub, all we had to do was fire up the PLC software, add the tank object, again, link it to the hardwired input, save it, download it, turn off the PLC 20% of the time, because everything from that point was a ripple effect, and it populated the touchscreen, the HMI, the historian, and even the mobility piece, which is, again, not apples to apples. So 20% of the time is what it took from a services standpoint or integration standpoint. So that gets us to the last one here, which is really driving it home. And because you're probably wondering, why do I care about Sparkplug? What's the value to me? What's the value of being an Eclipse Foundation Sparkplug working group member? Okay, so I'm going to touch on both of those. First one is just and this is for Chevron, since we use low bandwidth Ethernet radio systems, publisher subscriber in general uses only 15% of the bandwidth from our testing, as a pull response system does. So what that enables us to do is we can use some of these vendor standard fat objects, is what I'll call them. So let's say you have a tank level, one process variable with 100 different parameters wrapped around that one process variable, which is not uncommon. With pull response, we had to break them up into, a fast pull, which is the PV and the alarms, and the medium pull, and then the slow pull, and pull all 100 of those, at some point during the day, 24 times a day, or, once a minute, whatever. That publisher subscriber by nature just publishes what changes. So of course, when you instantiate it, yes, all 100 of them get pushed up, but from that point, it's just the PV. So seriously reduction in the radio bandwidth, unlike pull response. The next one is quite possibly the biggest one, is birth and death certificate. So what this gives us is session awareness. And if you are going to control any process where you could have upset conditions and possible environmental conditions, you have to know if you're connected to that PLC. I can tell you stories about lightning striking, knocking out power to a facility, and the tank level reading, 50% for 2 days. Operator in the control room's thinking, sweet, I can go take a nap. Well, he gets a call and says there's a spill because it was stale data. So that's why that's very important to have that session awareness. Now, the other thing that the birth certificate could allow you to do is if you get that up to a cloud broker, let's say, where you're doing your dashboarding and your analytics, if your, let's say, machine learning system can understand that birth certificate that comes through the IoT hub or what have you, you can automatically plop your pump or tank analytics onto that, and really you have a zero-touch provisioning of your dashboarding and analytics in the cloud. So that could be a really powerful thing, instead of paying a data scientist to do Control-C, Control-V on top of every pump and tank that you have. Let's see, the next one is Sparkplug accounts for the hierarchy of our facilities in the topic namespace. So if you think about it, you want to add your own dashboard. We want to make this available to the Chevron citizen. What are you going to search on when you go into your cloud historian and pull tags out? You're going to search on the tag name, right? So that's where your Chevron.upstream.northamerica.texas.Permian Basin, facility number 3, pump 101, that all shows up in that topic namespace. Whereas in regular MQTT, you've got to build that hierarchy in the JSON script. And we don't want our automation engineers to be JSON coders to try to have to build that in. Complete pain in the booty. So that's the big thing about the topic namespace for us. And then Arlen mentioned it, store and forward is built in. Years ago, we looked at, because with our low speed radios that could get interfered because they play in unlicensed space, you would see the temperature go up, boom, drop down to 0, then come back up later. You're never getting that data back. So with the store and forward built into your edge device, we don't have to worry about that. We were going to spend $10,000 per PLC to add a card to do that for us. But of course, that's cost prohibitive, and that never got out of square one. Next one is, this is steps in towards modernizing the PCN. So you think about it, there's companies already doing it, doing SCADA in the cloud. Well, if you're going from a typical SCADA system to SCADA in the cloud, that's a big jump. But if you put on your edge device and you can put a broker at level 3 and you're doing publisher subscriber to level 3, and let's say, some infrastructure goes end of life and you want to go straight to the cloud, well, all you do is repoint it to a different broker with a different IP address in the cloud. So that's one thing. It's one baby step into modernizing your PCN. The other thing is, I'll call it Modbus to oil and gas operators. If everyone used Sparkplug, and we do a lot of these property swaps back and forth, it takes us a couple months to get our Chevron Bless control system on there, or to get their control system integrated into our SCADA system on day one. And we kind of run blind until that time. We make people drive by and go look at that tank level. Well, if we had this on there, we could just repoint it to a cloud broker, spin up a new broker, because their pump number 1 is not going to be the same as our pump number 1. We would have that data coming in before lunchtime and not take a chance of having any spills. So that's that piece. Then, vendors have Sparkplug compliant PLCs and cards now, which is because of the last one, because we've given this to the Eclipse Foundation to manage this open standard. And if you're not a vendor, put on your vendor hat and think about it. Vendors are more likely to build a protocol into their devices if it's widely adopted across multiple industries, right? If we built a Chevron, and Arlen mentioned it, we could have done a Chevron MQTT flavor and say, hey, big company, will you build this into your edge devices, what have you? And they're going to say no, because that only increases their sales to Chevron. This allows them to build it in and service multiple industries and get a lot of value from that. And the other thing plus is, Chevron would spend or any end user would spend way more money and time managing their own specification than what it costs to be a member of the Sparkplug working group in the Eclipse Foundation. So that's a huge value to us from an end user standpoint.
Well, thanks, Todd. Really appreciate that. So now, Frederic, I'll let you go through the Eclipse specification project.
Yeah, absolutely. And this is really to give you an overview of how exactly we manage this open source specification and how things work at a very high level. So when we say specification at the Eclipse Foundation, it's important to realize this is not just about the document. The document obviously is important, but we also consider part of the spec, the API, okay, so the specific APIs that you will program against, and what we call the TCK, so the Technology Compatibility Kit. So the TCK is something that once it will be complete, because the spec project team is working on it right now, but essentially once this is complete, you will be able to download this and then test your Sparkplug implementation if you are an implementer against it, okay? So by default, the Eclipse Foundation specification process says that you need at least one open source compatible implementation of the specification. And when we say compatible implementation, it's literally an implementation that passes all of the tests and fulfills all of the requirements in the TCK, okay? And then our process means that we bundle a specific version of the document, of the TCK, and at least one compatible implementation. You combine all of that, and this is a version of the Sparkplug specification. So we are in the process of delivering this first Eclipse published version of the Sparkplug specification to the market. And Wes from CirrusLink will tell you all about this, is our project lead for the Sparkplug specification project. But you know, this ongoing process is really, really important because it is the foundation for everything else that happens around the specification. And someone in the chat was asking about, is there a list of Sparkplug implementation somewhere? So our strategic member IFMQ, they have a great landscape on their website. The URL is in the chat if you want to have a look at this. But once the TCK is available, we'll have a specific section on our website that will mention every Sparkplug compatible implementation that will have passed the TCK as well. And this will be the authoritative source. You know, if you're looking for a Sparkplug compatible product, then it will be the place to, the official place to look for. And this brings us to an important distinction about what we do at the foundation, the distinction between our open source projects and our working groups. So in this case, we have two really open source projects that are relevant to Sparkplug. One is the Sparkplug specification project, which is a spec project, right? And the other one is Eclipse Tahoe, which is the compatible implementation that's developed in the open at the Eclipse Foundation. And really projects at Eclipse, you know, they are about the committers, okay? The people that actually write the code and have the rights to commit new code to the repository. Okay, so this is about building code, specifications, documentations, and really our projects are meritocracies in the sense that they are self-organized. And when they want to invite a new committer, it's because a contributor has submitted, you know, pull requests that have been merged, and they feel that it's a valuable potential new member for the team. And the Eclipse staff has no power over the projects, right? In the sense that we are just there to ensure they respect our development process and our specification process, and that's it. For the rest, you know, the project lead and the committers are making all of the decisions. On the other side, there are the working groups, and well, you're literally at the first meeting, community meeting of the Sparkplug working group. And a working group is really a group of organizations, you know, and they are there to focus, promote, augment Eclipse technologies, and there's open governance. So we have a steering committee where all our strategic members have a seat. And then for participant level members, we are having elections every year to designate a representative on the steering committee. Okay, so all of that happens in the open. So, you know, election notifications and all of that go on our public mailing list. And really the point of the working group is to support the projects in a business perspective to reach their objectives. And a common thing between projects and working groups is that everything we do is transparent, open, and vendor neutral. And that's really important. So as a neutral third party, the Eclipse Foundation ensures that whatever happens in our open source projects, whether it's code or specifications, is really in an environment where all of the contributors have equal standing. So because CirrusLink contributed the spec to the Eclipse Foundation doesn't mean that they get preferential treatment or anything, right? And this is really important because this is what an open spec is about. And where the relationship between working groups and projects, you know, is an open-ended one in the sense that working groups, you know, they select on their own what projects they care about, and projects can be linked to one or several working groups. Okay, so it's a many-to-many relationship, and it's loosely coupled, except for spec projects. So spec projects have to live in a specific working groups, but then, you know, Eclipse IoT, which is a larger IoT community, has a keen interest in Sparkplug, and so they certainly care about the Sparkplug spec and the Tahoe open source implementation. So if you want to see whatever is happening right now, please have a look at the GitHub repositories for the Sparkplug specification and Eclipse Tahoe. And Wes will give you a bit more visibility into this. But really, the spec document is an open document on GitHub in ASCII doc, which is an industry standard, an open standard, which is also an Eclipse specification, by the way. And so you will find this on GitHub. The TCK is developed in the open in the scope of the Sparkplug specification project. And then on the other hand, Eclipse Tahoe, which is the open source compatible implementation. Now, coming soon, all of this would coalesce and really enable us to bring forward what we call the Sparkplug compatibility program. So essentially, the whole point of this is that you will have the Sparkplug compatible logo that you see, and maybe other logos for hardware. We are still designing the parameters of this. But essentially, in the frame of the program, what we'll highlight are really the implementations, whether they are open source or commercial, that are really passing the TCK for Sparkplug. Okay, and the whole point of this is to build customer confidence, right? When you see the Sparkplug compatible logo, you absolutely know that this software stack or this device is interoperable with any other Sparkplug compatible device or software. Okay, it's all about the collaboration. Obviously, between the various implementers of Sparkplug, we'll have marketing initiatives that will highlight not only our open source implementations, but the commercial products that will pass the TCK as well. And we'll work together on brand development and provide community support. So the details are still under wraps for now, but we will be communicating in advance about all of those things on our mailing list and in our Slack workspace. So if you want advance notice of those things, please join the mailing list if you haven't yet. And an important thing is that if you, you will need to be a member of the working group in order to be part of the compatibility program. Okay, so only working group members will be permitted to use the Sparkplug compatible logo in their marketing. So that's a thing, that we will introduce progressively. But if you are using the Sparkplug logo and name in your marketing, so this is a change that you need to factor in your plans for the next months. And before handing to Wes, my call to action. So you are there today, so thank you very much. I really appreciate it. Please follow us on our website. This is our main channel of communication, and you will find instructions to join the Slack workspace and the mailing list there. Please implement Sparkplug if you are obviously an implementer, whether it is in software or in devices. And please join our working group. I mean, this is an open process. This is an open community, and by joining the working group, you get a committer on the Spec project and have a voice in the future evolution of Sparkplug. So now, Wes, if you are ready, I think this is the point where I handle it to you.
All right, thanks for that. So let me share my screen here. I know everybody was probably tired of looking at slides. I don't have any slides. So So as Frederick said, I am project lead on both the Sparkplug specification project as well as the Tahoe project. So I'm just going to cover sort of at a high level what each of those things are and what we're doing in each of them. So this is the GitHub repo for the specification project itself. So the main goals here are really twofold. One is to develop the specification itself, and the other is to develop the TCK. Frederick mentioned that APIs are also typically part of a specification, but in our case, that doesn't hold true. So Eclipse holds the Jakarta specification project as well, where there is an API, right? They're developing against Java APIs, but Sparkplug's a little bit different because it's really an interaction between MQTT clients on a network, and also it's not language specific. So there is really no API that we develop here, but the specification document and the TCK are both being done out of this project. So I guess you might ask why we're developing the spec, because the spec was already written. The original version that Arlen, Chad, and I put together at CirrusLink really needed some work. So over the course of the initial few years where we opened it up and released it, other people started implementing it, but there certainly were some issues with it. Terminology wasn't incredibly consistent throughout the document. Also, there was some errata as well. There were things that were just fundamentally wrong that other people have noticed and also created issues on this project about that as well. So this is really a place for us to clean up the specification. So also in doing that, we're moving from the Word/PDF format that it was in previously to the ASCII doc format, also as Frederick mentioned. And so also we've broken it out into chapters. And so we also have a Maven build system associated with this, which also allows us to get better tracking information about the TCK and about the normative statements that are made in the document, and how those relate to the TCK to make sure that we cover all of the normative statements in the specification. So a normative statement is like a must statement. So for example, a connecting MQTT client that is an edge node must include a will message with a particular topic and a particular payload format with some particular components within them. So there are multiple different normative statements that are written in the specification that then we can track and make sure we have covered in the TCK. So we use Maven to actually build these tools or build these components that then give us information about where we are in terms of covering things in the TCK. So here's an example. So we've taken a lot of this from what was developed out of the Jakarta specification at Eclipse, and there are tools that are helping us in terms of how we do that work. So here you can see that we have annotations in the specification itself that don't show up ultimately in the document. So this right view is more like what the output document would look like that a normal person would read. And on the left side is actually the quote source code of the specification, which includes these annotations, which we then use as part of the development process. So here we can see that a primary host application must provide a will message in the MQTT connect packet, and it must be a UTF-8 string of offline. So these are some examples of those things that we can use within this build process to get knowledge about whether or not we're covering these things in the TCK. So this is sort of an example of what the code looks like and what it is we're doing. So we're trying to normalize the language, also clean up any errata that was present in the original spec. But long-term in future versions, we'd also like to add additional features. So of course, Arlen, Chad, and I didn't come up with every idea that was possible or made sense. And by opening this up, we've gotten a lot of feedback from our customers and also now partner companies that are implementing Sparkplug about things that could be done to improve it. And a lot of these are great ideas that ultimately we would potentially like to incorporate in. This first iteration, though, is really going to be about cleaning up and making the language of the original version more precise and getting it out and available for people to implement. And so with that, we have different output artifacts of our build process. So one of those, of course, is the actual specification document itself. So this is a work in progress. It's always available via this GitHub repo. You can go and run Maven against it, and it will create a local index.html file, which is the current in progress version of the specification. And so if you were to have read the original specification and now read this one, you'll see that a lot of things have been reordered to make it a little bit more specification-like in terms of being similar to other specifications that are officially available, like the MQTT spec, for example. In addition, we also get this coverage report that comes out of some of the Maven documentation tooling. So here we can see that we don't have a huge number of annotated normative statements yet, but we're beginning to get some. So from chapter 4, I showed some around the LWT associated with the primary host. So we do have 12 statements there, and then we can also see in the actual TCK itself how many tests actually apply to any of those individual normative annotated statements. And so here we can see that the TCK covers 3 of those 12, which gives us coverage of 25%. So this is just about what it is we're testing, not how some compatible implementation might actually perform against it. And then we can look at details down below about what is covered, what the actual statements are, which then gives us a target as we formalize the normative statements within the specification. Ultimately, then that will direct the work that's happening within the TCK, which we're really just getting up and off the ground right now. So with that, I do have a short demo. I'm going to try and keep it very short. So I'll go through it quickly, but in addition, there's actual code, right? So we're using JUnit 5 as part of the TCK. And because we have to interact with network devices, we have to do some more complicated things within our tests. So these tests look a little bit more complex than that you would with a standard test against an API and its associated implementation within the language of Java or any other language for that matter. So we're using some open tools from HiveMQ. So HiveMQ has an open source MQTT server, which they've contributed under the Apache license, which is compatible with the Eclipse license generally. So with that, we are able to spin up an MQTT server and then also create some tests. So what we're doing is using the test IDs from the document. So these actually come directly from these annotations here, which are then used in that coverage report. And then we can actually run a quote compatible implementation against it. So in this case, this is one of the tests that ultimately will be part of the test for what is a primary host application. So there are really 4 different Sparkplug profiles that ultimately will be part of the TCK. So that is an MQTT server. So again, some language has changed in the MQTT spec around requirements. So in the original spec, it said you needed a 311 compliant MQTT server. At this point, that isn't really true. You really need a subset of those components. And also it happens to be compatible with an overlapping subset of MQTT5 as well. And so some of the language is changing there. And so we will have tests that test your MQTT server compatible implementation to prove that it can work with other Sparkplug MQTT clients. In addition, we have the Edge node client, which is, I think, one of the ones that we've seen most people implement to date, but then also the primary host application. And also we have a notion of secondary host applications, which is being more explicitly broken out in the spec as well. But so with this, I can actually run this test. And what it does is it spins up a HiveMQ MQTT server, the open source version, and also includes this extension which I've written for it. So HiveMQ has this notion of interceptors, which allows you to intercept messages either leaving or coming into the MQTT server. And with that, I can actually perform tests within the MQTT server to make sure that I am in fact receiving an LWT in that connect packet, and also that it is structured in the way that it's supposed to. So what I'm going to do now is I'm going to use a it's not open source, but it is a free tool called MQTTFX. And so the HiveMQ MQTT server spins up on a different port every time. So it just told me what that was. I'm entering it in here. And now you can see I'm also going to include a LWT with my message, which is quality of service 1 with retained with a primary host on the appropriate topic with a message of offline. And so if I say okay there and then do a connect, you'll see it quickly connected and disconnected. But over here, you can see that ultimately all of the components that needed to be there were present and that the test passed. JUnit reported that with this green bar up here as well in Eclipse. And so my compatible implementation, at least with that subset of the TCK, is passing. So we have a lot more work to do around these different flows and creating the test for the various profiles, as well as formalizing the language in the spec. So this is really an overview of the work that's happening at the Sparkplug specification project. In addition, we're also working on things within the Tahoe compatible implementation. So because a good portion of the committers on both the specification project and the Tahoe project are very familiar with Java, that is going to be the target language for the compatible implementation here. But the original Tahoe, and before we just called it Sparkplug implementations that CirrusLink contributed years ago, it was really around encoding and decoding the payloads. There wasn't really a complete implementation of an edge node, for example, that actually connected and published its birth certificate in the proper way and all of those things. So there's a lot of work to do here, but ultimately we will use the Java compatible implementation to test against the TCK, and that will give us our 3 output artifacts, which are the ultimate goals of both of these projects. So again, that is the specification document itself, the TCK, and then this Java compatible implementation. We're really interested in getting additional contributors, especially in my view around Tahoe, because Java will be the only target language for the initial release. If there are other people, and I know that there certainly is demand for it, we get lots of requests around the C and also the C# implementation. Actually, all 5 that are listed here, there is certainly demand for. But all of these libraries are even barely encoder decoders because CirrusLink uses the Java implementation in our commercial products. It gets a lot more attention than the others. But certainly we'd be interested in any additional contributors that wanted to join and be a part of this, or even just find bugs and issues and submit those. So that's all I have. I don't know who wants the screen next. I think we're going to questions and answers here.
Yeah,
Yes.
Frederick, why don't you take over the screen? Wes, thanks. I hope everybody kind of, again, I didn't want to go into the gory details there, but I wanted everybody to see that I think it's disruptive in the way that we're using software. I mean, to Frederick's point, software is eating the world, and we took an industrial spec in Sparkplug, but we took it to the Eclipse Software Foundation because they've got the tooling that we need to be able to put this all together and to make it work long term, and to have people to be confident that the implementations of Sparkplug out there, we've got test coverage on those so that we keep that single source of truth, that plug and play capability, that interoperable capability, so that when Todd at Chevron buys a piece of equipment, he wants to know that, my golly, when he plugs that in, it's going to work properly. And that is the long-term goal here. So with that, we really would like to open it up. I think if anybody wants to unmute, ask a question, if you want to ask it in the chat window. Did we cover everything that everyone were interested in for the purpose of the call today? I think there's been a lot of messages on, hey, where do we go to get more information? How do we get started? But the Sparkplug spec is only going to be as good as the ecosystem that we build around it. So having customers join, having OEM partners join, I think is crucial long-term to this really exploding the industrial Internet of Things to where, it will let us scale like the Internet of People does.
Absolutely, and thank you, Alan. So there's a question in the chat. What is your time frame for the specification and conformity testing?
So I'll take that one. So we don't have a precise timeline at this point. So it really, in large part, depends upon the amount of contribution and time we get from the existing committers that are there, which definitely has ticked up quite a bit recently. I think we'll have a much better idea as to when we'll have this ready at the point that we get the specification document at least mostly complete, which the original target was the end of this month. And so with that, it will include all of the normative statements that need to be made, which gives us a scope for what tests need to be developed in the TCK itself, which then also will drive what exactly needs to be written in the compatible implementation. So I really hope to have a much better answer on that in the near future, but at this time we don't. And it would only include really those three things: the doc, the TCK itself, and also the Java compatible implementation.
I think, Wes, we can say certainly later this year would be a good objective, but yeah, there's a lot of work to do for sure.
Matthew, you can ask your question verbally.
Yes. First off, many hats off to you guys on going the route of open source. Really appreciate that. Exxon, yourself, and Arlen, and Cirrus. We've been trying to do implementations ourselves. We're finding for a specific use case some limitations with the spec, and we're just going off the PDF. So this was very informative for us that we can go to that GitHub repository and start reviewing where it's starting to move towards. We are interested in, this is an architectural change, but adding an additional level in the topic space between the group ID and the ndata, ddata topic path. I don't want to get into the details, but regarding kind of kickstarting discussion around that type of a change, what is the best way to go about that?
So I would say that posting a question or comment on the Slack channel is probably the best way. This is something that certainly we've had discussions about at CirrusLink based on individual customer and or other implementer requirements, that ultimately we've found workarounds that didn't require additional tokens in the topic namespace. I'm not saying that that's the case here, but it's certainly worth having a discussion on the Slack channel.
Okay, great.
I would say certainly that is not likely to be a change that would be included in the first revision of the specification, because that would be a pretty significant breaking change.
Yeah, that would be a 1.1 namespace or something like that.
Right. I should note, though, that is in large part why we developed Sparkplug, with the first token being a identifier of the namespace, which really isn't just a namespace identifier, but also a payload identifier. So in SPBV 1.0, you know that everything remaining within that topic namespace is going to follow the Sparkplug B format, which will also include the Sparkplug B namespace. And so the idea was that there could be C, D, E, F. Obviously, also there was already an A, which happened to be similar in namespace, but the payload encoding was entirely different.
All right. Well, I think, again, if anybody has any other questions, more than happy to. There's as Wes mentioned, there's been a huge uptick in the number of people that have joined the Slack channel and the number of interactions on that. So again, I'd like to take this opportunity, thank everybody for joining. Again, that call to action, if you can get your company or yourself to join the working group or join as a committer, that would be fantastic. With that, Frederick, I'll hand it over to you, and we'll probably call it a wrap.
Yes, absolutely. We are at time already, so thank you so much, everyone, for attending this first community meeting. Please subscribe to our mailing list if you want to receive invites to future community meetings. We'll make the recording available through our website, sparkplug.eclipse.org, so please have a look there. And in the meantime, please feel free to reach out over Twitter, LinkedIn, whatever channel you feel comfortable with. And we also we put the link, the invite link in the chat for our Slack workspace. So you are free to join that even if you're not a member of the foundation or the working group. So please come and chat with the actual people working on the technology there. So Arlen, Todd, thank you so much for your contributions to this morning's presentation. Thank you everyone for attending, and let's stay in touch. So
All right.
thank you and see you next time.
Thanks, everybody.